It's Make Your Mama's Proud time!
I love my mama!
Now, maybe you loved your mama, but you didn't love intro stats all that much. So let's just talk about the basic ideas that you need from that class in order to be able to do the homework and move forward in this one. Let's say we have a number line and we've collected data from two different groups, Group 1 and Group 2. If you can see well enough to see the different colors, great. If not, I'll just tell you. Group 1 has an average that's pretty close to the average for Group 2. And we want to test, are they really different? We got the sample averages here as different because random luck means there's fluctuation here. So the X bars are never going to line up right on top of each other. The chance of that's so small. But maybe the true values are actually equal to each other. This might be, for example, two drugs. We want to test, are they actually the same drug or do they have the same effect? Maybe this is bacteria on the East Coast and bacteria on the West Coast. We want to know, are they the same or are they different? So that is our null hypothesis. And so we're going to calculate a probability. Let's imagine that these two groups come from the same distribution. And if they did, what's the probability you get a bunch of data with this average and then a bunch of data with that average? If this probability is high, then we would say, yeah, this picture produces stuff that is pretty likely. So we're going to say maybe mu1 could be equal to mu2 because the data is probable. We can't say we've proven mu1 equals mu2, only that this data seems reasonable if mu1 really did equal mu2. If the p-value, on the other hand, was low, then we would say something weird happened. If they really were from the same group, then we shouldn't have gotten averages like that. This picture probably wouldn't work, but let me redraw the picture. See here, all of Group 1 was on this side, so the average landed here. And all of Group 2 was on this side, so the average landed over here. What's the probability that if you randomly got a bunch of data where mu1 and mu2 were the same, like this big overall picture shows, that all of your data would have been to one side and all of this data to the other side? No, that's really unlikely. It's so unlikely that either we are the luckiest people in the world, or we're going to say, no, there's not one picture. There's got to be two distinct groups. And that's often really exciting. Like, I've shown that these two groups are different and separated. So in general, when we're talking about testing two different samples against each other, we want to look at whether the p-value is large or small. If it's large, we're going to say we couldn't find anything to separate these two groups. They seem to be the same. You have to be careful not to say we've proven they're exactly the same, but at least our data doesn't show a difference. If you get a small p-value, then you can say, yes, we have found a difference. Often this is exciting because, hey, this is not behaving the same as the other one. And that's the key looking at those p-values. How would you actually calculate it?
All right, look, I'll show you how to do this in Excel, but I swear it's the only thing in this class that we're going to use Excel for. The only reason is we haven't learned how to use R yet. We're not there. Some of you may know how to do this in hand from your intro class. That's great. Some of you know how to do it on a calculator. That's also fine. And you can ask me if you need help doing different methods. But here we have Group A, Group B, and now I'm going to tell Excel I want a t.test. And here is Group 1. And here is Group 2. They don't have to be the same sample size. And then how many tails? For this class, two-tailed tests is going to be what we're interested in. Why does that matter? It's saying, is there one group that we expect to be more than the other? In this case, we just want to see, are they the same or are they different? I don't care which one is more or less than the other. And then which test? The paired test, equal variance, unequal variance. You may have learned these tests, and if you feel like a specific one is more appropriate than the other, that's great, you can use it. What you're probably going to need in the near future is going to be an unequal variance test. That's where we don't make any assumptions about these groups. And there is our p-value, 10%. That is a bigger alpha than the 0.05. And so what would we conclude? The groups cannot be shown to have a difference. Great. Let's try it again. I copied and pasted, but this time I'm going to give one of the groups, let's change this to like 37 and 30. I'm going to make these lots bigger. This group is now going to be way higher than the other group. 25, 24. Just looking at it, it's obvious to me that they're different. Let's see what happens to the t-test here. Now, this array versus, and we want two-tailed to see if there's just any difference. We'll do, and we'll test again. 0.005, smaller than the 0.05, which is our cutoff. And so now we can say, yes, these groups are different from each other. So there we go. That's the basic idea of how you can test two groups against each other, which is something you might run into in the near future.